Hey there, Engispherians! Today, we're looking up, way up, at skyscrapers, and answering a question that might make some of you a bit uneasy. Why do massive skyscrapers actually sway in the wind? And more important, why do engineers want them to move? It might surprise you to learn that the world's tallest buildings are designed to move. The Burj Khalifa in Dubai can sway nearly 2 meters at its top. But this isn't a design flaw. It's intentional engineering brilliance. Skyscrapers are like vertical beams anchored at the bottom. When wind pushes against them, they need some flexibility to avoid cracking or breaking. Think of it like a tree in the wind. Rigid trees snap, while flexible ones bend and survive. When wind hits a skyscraper, it creates something engineers call wind load. This isn't uniform pressure. It's a complex pattern of forces that can cause the building to sway side to side or even twist. As buildings get taller, these forces become more significant. This is why modern skyscrapers often have unique shapes. The Shanghai Tower's twisted form, the tapered design of the Burj Khalifa, and the sky gardens in Singapore's Oasia Hotel downtown all help manage wind flow around the structure. Now, every building has what engineers call a natural frequency, the rate at which it wants to sway when pushed. If wind pushes at this same frequency, the swaying can amplify dangerously, like pushing a swing at just the right moment. So how do engineers control this movement? Enter one of the coolest engineering solutions, the tuned mass damper. A tuned mass damper is essentially a giant counterweight that moves in the opposite direction of the building's sway. Taipei 101 in Taiwan has one of the most famous. A 728-ton steel sphere suspended by cables that acts like a massive pendulum. When the building starts to sway one way, the damper's inertia makes it want to stay put, then swing in the opposite direction, effectively canceling out the building's movement. It's like having a stabilizer that absorbs the building's kinetic energy. Some buildings use multiple dampers or even liquid dampers, massive tanks of water whose sloshing counteracts building movement. One World Trade Center in New York uses a combination of damping technologies to keep steady in high winds. Modern skyscrapers are also equipped with sophisticated monitoring systems that constantly measure movement and structural health, allowing engineers to ensure everything is performing as designed. The goal isn't to eliminate movement entirely. That would require impossibly rigid structures. Instead, engineers aim to keep the sway below what humans can perceive, typically under 1/500th of the building's height. So next time you're in a skyscraper on a windy day, remember, that subtle sway isn't a sign of weakness. It's evidence of brilliant engineering that allows these incredible structures to stand tall against the elements. Thanks for watching. If you enjoyed learning about skyscraper engineering, be sure to like this video and subscribe for more insights into the engineering that shapes our world. Drop a comment below if you have questions or suggestions for future topics.